My name is David Pacheco. You may have seen me as DAP. I feel like I should have requested some walk-up music. I don't know if it would have been like Edwin Diaz from the bullpen or something like that. I feel like I missed an opportunity here. But here I am. You've probably seen me in chat talking about software update. And so that's what I'm going to keep talking about this morning. I'm going to give, I want to get through kind of a lot of content here, and I will try to be mindful of the time. I know we have a lot of new faces, so I want to give a little bit of an overview of what we mean by software update and where we are with it, the road we've come, and where we're trying to get to. And then the sort of back half of this is a little bit more of an experience report on working on a long-term project like this, because as I'll talk about, it has been a long time, and there's been a lot of challenges that are sort of specific to that, but I think they will probably be pretty common at Oxide, if not already. And I'd like to start having more conversations talking about learning from each other on these things. So first, what do we mean by software update? Well, it's probably obvious. We mean updating all of the updatable software in the system. But what might be less obvious is how much updatable software there is in the system. So in a rack here, we've got 32 sleds or 16 sleds. Every one of those sleds has a service processor with its own OS image, has a root of trust with its own OS image, a root of trust bootloader, host OS, which has phase 1 and phase 2, two different parts. Then on top of that, we have the whole control plane. We also have the switches. Each of those also has the SP, ROT, and ROT bootloader. Those are different than the ones on the sleds. We also have that for each of the PSCs. Again, different components. And then in terms of the control plane, we have a storage component called Crucible that runs on every disk. And then we have like another like 5 to 10 control plane components that get deployed redundantly, sort of at large across the whole system. So it's a lot of different pieces. And actually, even many of these pieces are themselves divided into smaller bits that the update system, you know, God bless us, doesn't have to know about. So for example, the host OS also has all of our different networking services, LLDPD, Dendrite, Management Gateway, Megamite, bunch of stuff. We have CPU microcode that has to be updated in the system. We have NIC firmware. We also have SSD firmware, but that's not currently managed by the update system. So there's a lot of different software. It's all over the place. And people might reasonably be asking, well, we do have customers today. We have for 2 years. How do we update their systems if you're working on software update? Well, this is how we do it today. So all of the hard work that the engineering team does culminates in a zip file produced by our CI process that contains all of the updatable software on the rack. We put that through its paces. We install it on our dog food rack. We install it on our Colu rack, and we call it good to ship to customers. I believe this is the point at which our support team will reach out to customers and say, let's schedule time for you to do this software update. This is going to take a couple of hours of downtime, so we have to coordinate it with them. And it's also something where we are getting on their physical system. So this is a kind of a pretty important part for, as we'll talk about, but our support people are connecting to their system over what's called the technician port. This is a special interface we've built into the system for debugging and maintenance in emergency situations. It's not going through the main customer network. It's not going through our main API and all the authentication and authorization behind that. And they're generally going through what's called a jump box. So our support people are coming basically through the internet into a private box on the customer's network that is then able to connect to this special port on the rack, which, as you can imagine, customers are not all that jazzed about in terms of process for a whole lot of reasons. But you know, this is, for various historical reasons, this is where we are today. And then the question is, what does that procedure actually look like? Well, the first step is parking the rack, which is essentially turning off all of the control plane. There's a lot of other software that's still running, but the control plane is basically off. We replace all the software on all the systems at the same time. It's not exactly the same time, but since it's all off, it seems like the same time. We do a standard software update for the SPs, the ROT bootloader, host OS, all that stuff. Then we bring the whole control plane back up as part of that, but it initializes in a sort of idle state because the database schema is now out of date. Then there's a manual process to apply that database schema update, and then the rack is off to the races again and it's back up. So there are a couple of challenges with this, which we'll talk about. Oops, that's the wrong direction. The first is that it's not self-service, right? I mentioned that the first thing we do is we reach out to the customer to schedule time for us to get into their network and do it. This is sort of an, maybe it's an obvious non-starter, depends on what your background is and what spaces you've been in. We certainly have customers for whom the Oxide rack is physically in locations that our support people are never going to be able to get to. There are also like classified sites and places that people want to deploy this rack that like an Oxide person would have to be cleared in order to be able to reach. We also have more, I don't want to say prosaic, but sort of like ordinary enterprise customers that just don't want another person, another company's people in their network as like a matter of course. So there's that whole thing. There's also the whole coordination piece. There is also the whole downtime problem, which is that instances are offline for the duration of the upgrade. So that's about 1 or 2 hours today. That's a pretty big impact on users. It constrains when we can schedule these update windows, and it also constrains the type of workloads that people can put on the Oxide system to ones that can tolerate that kind of downtime. The other thing that's really important is strategically for us, it doesn't scale for us. If we want to have 100 customers, we can't be doing this manually on all of their racks, right? So this is a good time to step aside and talk a little bit about the role of software update, like as part of like what the company is doing. So first of all, it's been a top company priority for 2 years. Hopefully in a few more minutes, you'll understand why it's taken a long time to get to where we are. But it's important to realize that this is how Oxide continues to deliver value to customers after they've purchased their system. So they're purchasing this system with the understanding and expectation that the capabilities are going to get better over time. It's going to get more reliable, it's going to get faster, it's going to have more features and stuff like that. We have to deliver on that promise. And to be able to deliver on that promise, the upgrade process itself has to be something they're looking forward to. So the fear, not fear, but like the sort of anti-pattern I have in my head is like IT upgrades that you imagine from like 20 years ago, where you get an email that's like the whole thing's going down for many hours, and you come back the next day and it's like things aren't working. This is like the BART upgrade that happened last week and trains were down for 6 hours, right? This is the experience we really want to not deliver for customers, because that's going to make them not want to upgrade. Then they're going to start running into bugs that we've fixed that we can't deliver to them because they don't want to upgrade, and it's a real like vicious cycle. We want to be in the virtuous cycle where these upgrades are smooth, they're reliable, they're consistently making the software get better, and they're excited to do them every time. And they're not worried that we're going to take out their system. So obviously we need to be better operationalized to do that. This is what we're looking to build. This is the flow we're looking to build. And this has been the plan for a while now, which is, yes, we still produce this zip file that contains all the updatable software, but now it's the operator who's downloading that from us, validating it however they want. They're downloading it to their laptop or desktop or whatever it is, which is kind of an important step. I'll mention in a second. Then they're using the API via the console or the CLI to get that whole zip file up into the rack. And the rack will take care of distributing that software everywhere it needs to go within the rack. The operator basically just presses go. They go off for probably a while. The first couple of these are going to take a couple of hours, as we'll get better at the time, but it's going to take a couple hours to start. The system's going to go off and update those hundreds of individual components that we talked about while keeping the system up. The important thing here is that the operator really only has like 2 or 3 steps here. They're really just controlling policy, which is like, what release do I want you to be running? And like maybe there's a control for like, stop, something horrible has happened, please stop. Obviously, you need some kind of operability stuff, but they're not thinking about all those hundreds of components. And that's a huge part of our differentiator. They don't have to think about them when they set up the rack, and they don't have to think about them when they're updating the rack. And of course, the goal is that this scales up well with the number of racks. So if you're deploying a multi-rack, like single coherent region, then you're still doing this process once, and we're going to gradually update all of the racks in the system. The reason I mentioned the bit about them downloading this to their own system and then uploading it to the rack is that for a lot of maybe obvious reasons, a lot of the customers we care about operate with an air gap. Their system is not connected to the internet. So the rack is not pulling the software down from Oxide behind their backs or transparently. This is something that they are pulling down themselves and then uploading to the system when they're ready to do the update. We could imagine something like that working for customers that want it in the future, but I think there's been relatively little interest in that among our current customers. They're much more interested in making sure that we don't talk to the internet. So this self-service update process implies a bunch of things about the implementation of upgrade, right? One is that it's API driven. One is that it's fully automated, which means that the control plane is driving the update, which means that the control plane is online for the whole process of the update, which is really hard. So there's a lot of metaphors used for this. I'm sure folks have heard this. It's changing all the parts of the car while it's driving down the freeway. It's changing all the parts of the plane while it's in the air. But it really is really hard. It's kind of amazing that that we can do it, and also that it's table stakes basically everywhere. Systems are expected to be able to do this because we are, you start at a version of the whole system where everything is running the old software. You're going to get to a world where everything's running the new software, but you've got hundreds of intermediate states where you've got old software right next to new software, and that involves making sure that those are always going to be able to talk to each other, which is a very complicated problem. How do you make sure that at every single one of those intermediate states, every combination of components that talks to each other is able to still do so? And so the fear here would be that we make a mistake here and we wind up in one of these intermediate states where the system is now stuck because we messed this up, and now we can't proceed out of that. So a lot of the work has gone into making sure that that process goes smoothly and we don't have that kind of problem. Okay, so how have we gotten here? Or how have we gotten to where we are? We could go back really far, but before MVP, the focus was on the minimum upgradable product, which is where the term update comes from. The process I was describing for how we do upgrades today is based on that update, which is it's a process that was envisioned to work for things like sled recovery, where very little of the system is already working. And it works really well for that. We built that as a foundational piece first. It's not the best upgrade experience that we want, but we did it first because we knew we needed it. It covers more cases and things like that. About 2 years ago, OxCon 2023 is around when I started working on this, which is actually newer, I think, than most of the people on the update team. As I was thinking about it, most of the people on the team have actually been working on this for longer than me, even though it's been about 2 years. And at that point, so 2023, 2 years ago, we had just shipped our first customer system, and upgrades worked basically the way they do today. But we were starting to think about what the vision would look like, and it's basically what I just described. It's this autonomous self-service system with opportunities for risk mitigation so that upgrades don't go terribly. And a big part of it was around what foundations are going to allow us to do that. One part of this is this distinction between policy versus planning versus execution. So policy is what the operator wants us to be doing. Planning is a very specific set of steps that the system wants to take in order to make that policy happen. And then execution is actually executing those things. Sounds really obvious when you say it, but that's actually not how we build most software most of the time. And it's an incredibly useful pattern for us for an autonomous system like this, because it allows us to decouple planning and execution especially. So we can build this planner that is divorced from all the steps actually required to make a plan happen. We can do all kinds of testing on that and test basically all the decision making that the system would do under all kinds of conditions that we don't have the time or resources to go construct, make sure it makes all good decisions in those cases. And then separately, we can go test this execution thing, which is like, given a plan, any kind of plan, can you go execute that and make reality match that? And that's a huge point of decoupling that allows us to have a lot of confidence in the system. Operability was another big theme. So being able to ask the system, what are you doing and why are you doing it? That's another thing you get out of this plan execute pattern, is you can say, why did you make that plan? What's the difference between that plan and the plan you had 5 minutes ago? What would you do if I did this? So these are important things for operability. And again, this all goes back to risk mitigation and making sure that the upgrade process goes smoothly. I'm going to go as quick as I can through this. So this first year after that, so this is 23, 2024, were basically the foundations of what we now call dynamic reconfiguration. The customer deliverables here were things like sled expungement and sled add. So being able to take a sled out of a rack and add a new one to a rack. Again, sounds super easy, right? But there's a bunch of software and data stored on that sled that you want to remove that we need to account for now and restore fault tolerance and all that stuff. Well, this turned out to be not one project, but like a whole bunch of different projects. I'm not going to go through all these. I did this last year. But every single control plane component has a little project associated with dealing with the fact that instances of it can come and go at runtime. And so that's what a lot of that first year was about. The other thing we spent a lot of time on in that first year were the foundations, inventory and blueprints that make up that plan execute pattern. So inventory is the process by which the control plane reaches out to all the things that it can find and just learns about what's there, what hardware is there, what sleds and switches are present in the rack, what software is running in each of those things in its SP, in its ROT, what host OS is it running, what control plane zones are running. And obviously that stuff can all change from minute to minute. An inventory is something that once you've collected it, it's immediately potentially out of date, but you also still need to know what reality is in order to make any decisions. So the inventory system is one big thing that we did. And the blueprint system, the blueprints are the plans I was talking about. So a blueprint is a mostly declarative description of the system that we want to be. So it'll say for all the components that are out there, what version of software should each of them be running, and what configuration should they have, and all that stuff. So anytime the control plane is making a change to what is deployed out there, if we're going to update a service processor software, or we're going to deploy a new Cockroach DB node or something like that, we generate a new blueprint that reflects that reality, and then we do this execution phase until inventory reflects that reality. So that's kind of the first year, and so the basics of the system. At OxCon 2024, I came up here and I did a similar sort of update. And what we said was next was these three things. One was dog food of Theseus, and this was basically that the name is a reference to the ship of Theseus. This is like you replace all the parts of a ship, is it still the same ship? So we wanted to say, okay, we believe that we have implemented sled replacement completely correctly. Let's do it on dog food. Let's take all of the sleds in dog food and expunge them from the system and then re-add them to the system so that we still have all the same hardware, but all the software has basically been rejiggered as though we had replaced all those sleds. Unfortunately, we ran into a sort of hard limit with the LRTQ limitation. Hopefully, Real Trust Quorum will allow us to revive that project, but we were able to de-risk like almost all of that. I think we have a lot of confidence that that would work once we address that. There's a bunch of work done on multi-node ClickHouse, which I'm mostly not going to talk about. We did a lot of this work. We ended up deprioritizing it for various reasons. And then what we said we were going to do is the first steps towards upgrade. And we had a big team meeting back in Burroughs where we said, okay, so what are we actually, we built all these pieces for add and expungement. How are we going to actually start doing upgrade? What are the first demos we're going to be able to do? And this is where I think it was both very useful, and I feel like I learned a valuable lesson here, which is we had put together these end-to-end demos, end-to-end-ish, that cut through a lot of the work that we had to do. So the very first demo we had was, let's be able to to upgrade a particular control plane zone. Like which one? Doesn't matter, whatever's easiest. And I think we picked Crucible Pantry. What about API dependencies between that thing and anything else? Forget it, don't worry about that. What about persistent state? Like we'll pick one that has no persistent state. But even that demo actually involved so much of the update system already working that at the time I remember thinking like, this is not that far away. This is like 3 or 4 or 5 or 6 weeks away. John, I think, knew that it wasn't. Maybe everyone else knew that it wasn't. It was actually several months before we got there. And along the way, we had actually put together several other very useful demos. So like a prerequisite of that is actually being able to upload a tough repo to the rack and then distributing all of its artifacts across the rack so that we have the software in the place we need it to be when we go upgrade that zone. That was its own project. That had its own demo. So like that actually probably should have been one of the first demos. That's kind of a lesson for me. But we wanted to be driven by this sort of end-to-end demo to sort of have this lodestar where we're trying to get to, but I think it was also important to have had demos that were smaller than that. So in the last year, what have we done? I could talk about every one of these things for quite a while, and I'm going to try really hard not to, but they're pretty important. So I'm actually going to start with a third bullet here, which is upgrade mechanisms, because this is probably what people think of as all of upgrade. So we need physical mechanisms inside Nexus to be able to update every control plane zone, any service processor, any root of trust, its bootloader, host OS phase 1 and phase 2. Fine. We got to go do all those mechanisms. Every one of those like comma separated items is like a person doing a month of work, basically. Then there's a planning aspect of that, which is like, okay, we have a way to do that, but we need to orchestrate the planning of that. Actually, something I want to going back to the execution thing. A big part of the challenge of that is that in order to survive failure of any particular hardware component, the control plane, the guts of the control plane is Nexus, is deployed redundantly across multiple sleds, right? So we always have 3 instances. But that means that how do we make sure that our multiple instances of the control plane are not trying to do the same thing at the same time and stomping on each other, or worse, doing different things at the same time that are working across purposes. So a big part of execution is also phrasing every one of those operations in terms of something that can be executed concurrently in a safe way. That was a big part of it, particularly for SP, ROT, bootloader, all the stuff that's managed by MGS. That needs to work even if multiple Nexus instances are trying to use MGS to update the SP at the same time, for example. Okay, so then we have the planning bit, which is, okay, now we have the ability to update each of these components, but how do we put together a plan that makes sure that we do it in a sequence that will work and in a way that doesn't destroy the system along the way? What do I mean by that? So the control plane has a database, the control plane database. It's in CockroachDB. It's a 5-node cluster. We need 3 nodes working at any given time to be able to work at all. So we would definitely want to make sure that we don't ever try to update the SPs on all 5 of the nodes hosting CockroachDB at the same time. That would be really bad. So there's like 100 other constraints like that the update process needs to ensure are true along the way. So it takes individual steps. Each step is a new blueprint in order to get to where it's trying to go. Let's see. Tough repo management is, I kind of already mentioned this, being able to upload. I forgot to mention the zip file I was talking about earlier, we sometimes call a tough repo. That refers to the internal structure of that zip file. So we use them kind of interchangeably. But you need to be able to upload that thing, distribute it across the whole system. And there was also a project around trust for that, because we don't want you to be able to upload any tough repo and we'll just install whatever it is. We want the operator to be able to say, these are the things that I trust. And so that's its own thing. I want to talk a little bit about API versioning, not because I did a lot of the work on it, but because I think it reflects a different part of this problem, which is, I was talking earlier about all these intermediate states and how do we make sure that we don't wind up in an intermediate state in which things are broken. And one of the ways we try to deal with that is to identify reasons why it would be broken, like inter-API dependencies, and make sure that if those get broken, we figure that out at CI time before a change lands, not when we're in the middle of an upgrade as part of upgrade testing, like after we think we've cut a release candidate or something like that. How do we do that? It's basically leveraging the same approach we've done first with Rust in the first place, and then we've applied via Dropshot and Progenitor to our network APIs, and building a bunch of tooling around developer workflow that basically says, if you want to make a breaking change to an internal API, you can do that, but you have to support the last release's version in the same in a particular release. And we can tell that at CI time. If you break that, the tooling will currently fail and say, hey, you changed this API in a way that's not compatible, so that we're catching really at development time, before even CI time, that this is a thing that would break upgrade. And this is a theme, this has been a lot of the work that we've done, is trying to create guardrails for ourselves so that the whole engineering team doesn't have to be thinking about upgrade constantly. We're creating these guardrails so that we know when we're breaking things. That's the planned work. Then there's a whole bunch of unplanned work. And you could argue some of this maybe we should have foreseen, but software is hard. So certainly we expect we're going to have to do some work on the foundation. And one of them is this planner sequencing thing. And again, there's a lot of slides here where I could talk for quite a while about all the bullets, and I'm not going to hit all of them. I'll mention planner sequencing. This came out of an issue in Colo, I think, right before OxCon last year, where we had a situation where the system was basically stuck, and we wanted to use Reconfigurator, which is the engine behind all of this stuff, in order to get it unstuck. But the execution process we built was sequential with dependencies between these steps. And if it failed at step 9, it wouldn't even try step 13, even though many of these steps are kind of separate from each other. So, I mean, many of them are related, which is why it looked that way, but some of them are not. And in that case, if we had managed to do step 13, we could have used Reconfigurator to get us out of that situation, but we couldn't, so we couldn't use it. So this was some work on foundation, which was, okay, what we're going to do is we're going to make it so that all the execution steps that happen at a given time are truly independent, which in some cases is just not bailing out when we fail here, but sometimes it's phrasing each of these things in such a way that if its dependencies haven't already happened, then they just fail quickly, and that's okay. We just move on anyway. And then the next time around, we will hopefully have done its dependencies, and we just keep trying this stuff forever. That's just one example. Another one that I like to talk about is this mupdate and update coexistence, which is something that I don't think we really thought about until early this year, which is that the way we were building the update process was actually going to break the existing mupdate process. By that I mean, the mupdate process assumes there's exactly one version of every piece of software that could be on a system on that system at a time. But that's not actually how we always do updates, right? We're going to be, you might have a couple of instances of something on a machine and they might be at different versions, and that's okay. But that means we needed a richer data model, so we moved where this stuff was stored somewhere else that better reflected that model. But that meant if you updated a sled that the update system had already updated, you would be replacing all the software that it wasn't using, which is not helpful. And so that's one part of this. The other part of this is that the update system believes, rightly I think, that it is in control of what software versions are deployed everywhere. So but we understand that there can still be emergencies. We may make a mistake and say, oh crap, we actually need to go update this sled or even the whole control plane because we just deployed an update that doesn't work or something like that. The last thing we want is for the update system to immediately start fixing it again. That is to say, breaking it again. And so what we needed is a way to what we call having the update system honor the update in the first place, which is to run the software that the operator was trying to deploy, and then stop doing anything else until it gets further direction from an operator. When it gets further direction from an operator, then it can proceed with whatever the operator has told it to do. But it also needs to account for the fact that it doesn't necessarily know what software was just installed, which means it's hard for it to know that it's safe to update it in the way that it would normally update it because of all the API dependencies we just talked about. So this is all really complicated, and Rain did an amazing job on this project. But this was like a whole thing that we hadn't really thought of that we ended up doing. We also ran into a bug in CockroachDB around decommissioning, which I want to mention because it's an interesting example of prioritization, which we'll talk about a little bit more later. So we can add and remove CockroachDB nodes to the cluster. And Cockroach is pretty good about stuff like that. At some point, we would like to be able to tell it, by the way, this node we removed, it's not just like gone because you haven't talked to it for a few minutes. It died. That sled caught fire. It's in a dumpster somewhere. Like, it's not coming back. Stop thinking about it. Don't try to talk to it anymore, whatever. But we did run into a bug in CockroachDB where if we decommissioned a node, concurrently with Cockroach reacting to the fact that it's gone, that it just independently noticed it was gone, Cockroach would get itself into a really bad state where the whole cluster was not working. It's a really bad kind of problem. And what we ended up, we tried a couple of ways. It's an annoying problem because it's a race condition. It's a narrow window. It's in software that is basically 2 years old now because we were a little behind on Cockroach updates for its own set of reasons. But it's also just like not that big a window. So it feels like if we just wait long enough to do the decommission, then we can do this. And we tried a little bit to do that. But the more we got into it, the more we realized we actually can't do this easily. But also, it's not that big a deal if we don't. And that's why, in terms of prioritization, we wound up punting it. And so I'll talk more about that later. But this is what I would call an important non-blocker, which is something we want to go resolve after we ship. It represents an ongoing risk in some sense, but it doesn't have very much impact. It's not actually a very big risk. And so we're not doing it for the initial release. There's lots more here, but not going to talk about it all. OK, so where are we? We have said that we're delivering self-service upgrade in release 17 with a release candidate expected at the end of this month. And I would say the same thing that I have been saying for about a year, which is that the schedule is tight but doable. I'm actually feeling pretty good about it. The last two big things are Nexus handoff that Sean and I are working on. This is the project formerly known as Database Schema Update, but wound up being kind of a more general case of Nexus handoff from old Nexuses to new. And the other is console support that Crespo is working on. And then there's kind of a long tail of loose ends, but there's a decreasing number of those that are truly that important. So I think we're in pretty good shape. What's more interesting, I think, is this question of the important non-blockers. And so these are the things that we've punted for the initial release, but nonetheless represent ongoing risks. And I'll talk a little bit about those. There's kind of a lot of them. I mean, I do want to be candid about that. But every one of these is something that, you know, we thought carefully about, and we're like, yeah, that's not strictly speaking a blocker, and we can at least ship 17, but we do need to circle back on these things. So the first one I mentioned is a catch-all for developer guardrails to catch upgrade breakage. Obviously, you don't technically need that in order to ship, but the longer we go without having those, the more we increase the risk that we don't discover a bug until late in the process, possibly even during an upgrade at a customer site, which is obviously scary. This is not one thing. This is like 10 things. And so we've done a lot of them. We may or may not get to all of them. 4745 is an interesting one. It says lack of rack health checks. So what I mean by this is that today, when we do this update process, our support team is on the tech port, and they have a health check script that checks a whole bunch of things, which is great. Those things are not checked by the product itself. So when we move to a world of self-service update where people are doing this without our support people involved, there's a risk that something is broken in a way that was previously caught by our health check script and we would have fixed at the time, but we actually don't notice. And the scariest one of these is that some fraction of the time when we update Cockroach, one of the nodes doesn't come back up because of a time sync issue. And that's really scary because if you don't notice that, it's not a big deal at all. But if it happens 2 more times, we're cooked. We lose the Cockroach cluster. So we really want to know about every one of those and make sure that we fix them, but that requires having these rack health checks. And it's an interesting example too, because it has nothing to do with update. It's more of a gap that we already had that becomes more important now that we're taking more of our support out of the loop for ordinary maintenance like this. Switch update risks is kind of another thing in this bucket. So this was also kind of a funny one because I feel like a lot of people knew about this, but some other people, including me, didn't know about this. And so it was a little bit of a recent discovery, which is that if we, let me see if I can get this right and people correct me if I got this wrong. If we have an update for the SP software that includes a new FPGA bit stream for the sequencer FPGA, we get a different type of reset that happens as part of the SP update that the scrimlet, which is the sled that the switch is attached to, does not handle very well. The scrimlet needs to be rebooted in order to restore service. All right, I got some thumbs up. That's good. That's a good description. This is kind of a problem. It's the kind of thing where like we've known about this for a while. It's something that I think people who do work in this area just deal with. That you bounce the box or whatever. But it has big impact for the upgrade system because we do update the SP, and we might take such an update. We've deemed this not a big risk for 17 because we don't anticipate having such an update in 17, and I'll talk more about the first updates that people will do, but it's an ongoing risk because as soon as we need to deploy an update that has an FPGA sequencer bitstream update, then we will have this problem, and we need it to be deployed in the software we're updating from in order to deploy that, which is a challenge. There's a bunch of stuff in the archival cleanup bucket, which is like, we're creating all these blueprints, they're sitting in the database, they're growing forever, we should probably clean those up. Infinitely growing databases are not that great. And then there's a whole bunch of other stuff here. And it goes off the slide, obviously. There's not a ton more, but there's a few more. A major risk I do want to call out is the lack of automated end-to-end testing. And this is a combination of the only environments where we could do something like this would be racklets and A4x2. There was a project to do this for A4x2 that has kind of stalled out. And then there's a plan, I think, to get a bunch more hardware to be able to do stuff like this, but that is not currently done, which is obviously fine and understandable, not blaming anyone, but it is an ongoing risk that we don't have that. In particular, the types of things we'd love to be doing all the time are updating from the last release to the latest commit on main. It doesn't have to be a blocker for landing every commit on main, but it sure would be nice to be doing that constantly. We'd be able to get a lot more miles on the tires for upgrade also. That tests upgrading to a commit. You also want to test upgrading from every commit. So we presumably would do something like install commit n-1 from the tip of main and then update to the next one, which actually tests updating from n-1. And then there's also tests for update and update together that we'd like to do. Now the next roadmap deliverable after we do this release 17, so we have release 17 delivering self-service update. We've got these important non-blockers, which are probably going to be a bunch of work we need to go finish up. The next roadmap deliverable is non-disruptive update. And so this is a little bit of a challenge of self-service update, is that I said that in the update process we have today, we take the whole rack down for a couple of hours. In the self-service update world, without this project, we are not taking the control plane down, but we are still bouncing all the sleds, which means every VM in the system will experience what looks like a reboot to them at least once. Some of them may experience more than one. And that process is going to take a lot longer. It might be 5 or 6 hours. So a given VM might actually be up for longer. It might be down for less time than it was before, but it'll definitely take a bunch of interruptions. And that's not ideal. What we would like to have, again, going back to that vision of customers being excited about upgrades and not having this impact to worry about, we want to get to a world where, as far as customers are concerned, while we're updating all the software in the rack, they don't see much of a disruption at all. And that happens by live migrating all the VMs across sleds before we reboot the sled so that we don't see that disruption. The first part of this problem is doing the live migration, and there are some dependencies there that need to happen before the upgrade project can actually deliver on that promise, although the work is not strictly blocked on that. But then there's the question of how do we make sure that the system has capacity for you to do this? This gets into some operator experience questions too, which is we might reasonably want to ask the operator, hey, do you want me to hold back some of the capacity in the rack so that when you do this update, I will have capacity to move stuff to so that we can do this update non-disruptively. And we have to figure out how we want to phrase that. Whether or not the answer to that question is yes, there's still this question of like, what choices can we make in scheduling, choosing where VMs live to make sure that we do have capacity if there could be capacity available. That's pretty important too. The original plan for this was Q4 of this year. I think, stay tuned. I think that's pretty likely to not happen in Q4 this year, but it's also much, much smaller than all the stuff that we've done so far. So it's not going to be huge. Was there a question? Yeah.
The question was, when you're looking at reservation of space and operator controls for that, are you considering prioritization of existing workloads to allow for like ephemeral based VMs that could be killed rather than reserving space as an option?
I'm not sure how much we've talked about it yet, but it's definitely something we could do. And the trick with that, as with all of the stuff around upgrade, is figuring out an order of doing things that will allow us to deliver something useful as quickly as possible. So, on the one hand, we know that there are customers today that are going to have ephemeral VMs. And so that is to say, ones that we can't migrate because they're using this like ephemeral local storage, or they don't care whether they get migrated because they're handling that at the application level. And there are a lot of different choices that we might want to make for those workloads, but we have to kind of figure that out. And as an example, so if you're a customer that all this stuff is transient, you actually don't want us to do what we are doing today with self-service update, which is one sled at a time, being very careful, updating one thing and then waiting for it to come back. That's why it takes 5 or 6 hours. You might actually rather we just update like 15 of the sleds, or as many sleds as we can first, and then we'll probably have to go step by step through the last couple that have cockroach on them. But that would make the total window a lot smaller. The impact would be much higher, but you don't care because you've got a bunch of other racks or something like that. So yeah, there's a lot of stuff we can do here, and it's a question of prioritization.
So if there's an issue in the field with some latest release, like where you had some sort of whatever it is that the customer wants to roll back, I assume the update process can also go backwards?
That is a good question, and not really. Rollback is really hard and is not something we have in the first version, or I should say automated rollback. I'll talk a little bit more about like the questions around that and like in general around prioritization. The challenge with rollback, so yes, I started off with these fears of a botched upgrade. The obvious thing you want to do is like stop it or like go back to the last version that worked. And it's a very like obvious thing that you want to do. It's challenging for a lot of reasons because all of our software that writes stuff to disk can change as part of the update, and the stuff that it writes to disk, that format may have changed. And it is obviously possible to build software where you only make changes to the format that the older software could also read, but it's very hard, especially if you also want to be able to add any features at all to the software. That's really tricky. You almost always wind up with what's called like a deferred update or a finalizer or something which says, I've gotten pretty far through the upgrade process, I'm running the new software, but I'm not using any of the new format features or whatever. Take a look and see, does the thing still look okay? And then you cross this Rubicon and say, I can't go, if once the operator said it's fine, then you can't go backwards across that. That's a common pattern in a lot of systems with state. We have this in the context of Crucible. We have this in a couple of other places in our DNS servers, but the big one is the control plane database itself. If you change the cockroach DB schema, and the sort of like worst case that I think of for something like that is, let's say we get a new feature request for some new type of authorization on an instance, where this shows up as a new field in the instance table that affects access control for that instance. And we roll out an upgrade, we add that to the schema. Because the control plane's online, a customer immediately starts using that in the new API, is using that field. Now we discover the upgrade is a disaster. What do? We need to get back to a database schema that doesn't have that field, but it's not safe to just drop it because that field might have actually been very load-bearing semantically. And it doesn't have to be security, but that's just a very visceral example. So anyway, this is just why rollback is hard, and we will have to figure out how we want to do it. We always have the backstop of being able to update to a particular version of the software. So the idea being, if the update system just messes up arbitrarily badly, the plan would be to update all the systems in the rack back to a version that is known good. And that would be a support process just like it is today. So maybe a better way to phrase it is what we're building is a system that in many cases, on the sunny days, allows support not to be involved so that the customer can do this on their own, but there will still be cases where support would have to be involved to do something like that. And any kind of impact in terms of on-disk stuff, we would have to evaluate at the time. I think we would try pretty hard to roll forward, honestly. Just like, you know, we had a regression in the 16 update, and the answer there is to roll forward. But to that point, that experience in the last couple of weeks made me wonder whether we want to build in a similar switch in upgrade that's like, we've gotten 90% of the way through the upgrade, but before we've committed to the schema update, are you ready for us to proceed? We probably would have been able to tell at that point, I think, if something in the networking world wasn't working well, and that would have been an opportunity to stop. But it's tricky. Any other questions on that? Should have just said no. Yeah, there's actually an RFD. I should have just said read the RFD. There's an RFD on Rollback, which basically says don't. But yeah. Okay, so I want to shift gears a little bit and give this sort of experience report for working on a long-running project like this. And again, my goal here is to share this experience and start conversations with other groups that are having similar experiences and try to share what has been working well and what hasn't. I want to be candid, though. It's a little bit of a hard thing to talk about. We're talking about the things that we've done, mistakes we've made, and it's just like kind of hard. We'll get into it. Yeah, I already gave that. Okay, so I've talked about some of my big fears about the update runtime, like what happens to a bad update at runtime. But my big fear, and I have a lot of fears, is that my big fear about the project was that it would feel perpetually a year or two away. When I started 2 years ago, I think it felt a year or two away, but my fear was that it would be perpetually a year or two away, because when something feels a year or two away, it's very easy to make day-to-day decisions that ensure that it will continue to be a year or two away because it feels so far, right? And I've seen this in my career a whole bunch with these projects that they tend to be big, ambitious, hard to do incrementally. That's a big like risk factor for this problem, I think. And it's very hard to get them to land because the default disposition is perpetually 1 or 2 years away. You have to actively take a lot of steps to make sure that you're bringing that thing in for a landing. And so how have we been doing that? And I kind of broke this into focus and prioritization, but you know, those overlap a whole lot, and I don't know. A lot of this is a little vague, which is part of why it's hard to talk about. So some folks have heard me use the term organizational procrastination. And so what I mean by this is that at every single point along the way, the path forward for upgrade has been unclear. It's been very hard. We have seen so many cases in front of us where there are circular dependencies, and so many cases where it's actually there are no dependencies. You have 50 things to do, and you can do them in any order because you won't have a thing until you've done all 50 of them. But then it's like, well, which one do I do next, right? So you have all these like hard things, and I actually want to talk specifically about that's in the large, but even in the small. So I worked on something in February called Service Processor Update, where I actually started with a working implementation of SP Update in Nexus that John had already done. Like, it was one of the very first things we did 2 years ago before we shifted focus to dynamic reconfiguration. But it wasn't suitable for the reconfigurator model in terms of concurrency and persistence and all that stuff. So we needed to rework that. And I'm like, okay, but do I start with the execution part of this? But if I start with execution, like, how do I actually execute it? Because all the execution stuff we have is based on a blueprint. So I guess I got to do the planning stuff first. So I'll build the planner part first. But how do I do the planner part? I need a data structure, but I don't know what that data structure would look like because I don't know what the execution part looks like. So this is a classic circular dependency. This is such a small part of the whole update project, and yet this just happened everywhere where you're like, I'm not sure what to do next. The specific answer here turned out to be a useful tool that I didn't realize how many times we'd applied this until I was putting this presentation together. The answer here was basically define the data structure as the interface between these things, expect that it's going to change, but then you can sort of work on both of these things at the same, not necessarily at the same time, but you could work on them at the same time, but they're at least decoupled. Anyway, so we have all this vagueness in the big update bucket. That's, by the way, only a year or two. It's a year or two away, so we don't have to worry about that right now. But then we have all these other really important problems. Some of them are urgent and some of them are not. Every one of the things, so John had given me a couple examples to use here, And I was really torn. So John had a couple of examples of things. He's like, throw me under the bus. I don't mind being thrown under the bus for this because I want you to talk about this. And there was stuff that was like, I spent an afternoon writing documentation for this thing, or the MGS protocol integration you did for Wireshark so that we could look at that stuff in Wireshark. And he gave those as examples of this. And I was like, but I don't want to discourage those things. But that reflects exactly the challenge here, which is they're all good things. We have so many important problems. And when they're well understood, we have this tendency to gravitate towards these important, well understood problems. I know exactly what to do. And how can it be wrong? I'm solving an important problem. And that's right. But also, I think if we make that choice even 20% of the time, we never finish the update project. And so that's hard. That's really hard. And that's what I've sort of called this organizational procrastination, which is just like procrastination. You don't want to judge yourself for it. You want to be aware of it and, work on trying to be intentional about the choices you're making. So fine. The other way I've kind of summarized this is how do we avoid letting the many small, well-understood problems just completely starve work on the big long-term project problem. And it is a balance because we also need to do a bunch of other things. So I was thinking about this and trying to figure out like, how can we, not exactly like a framework, but like what are the ways that we tend to lose focus when we do lose focus? And this happens to all of us. One I found is we get stuck on technical issues. A4x2 isn't booting. My A4x2 fell over. I'm fighting with diesel. I can't get this thing to compile, and I've been working at it for 2 hours. That's one type of, we get stuck on technical issues. We get stuck because we don't know what the next thing to do is. That's the thing I was just talking about. And the other is we run across other important problems. And I was showing this to Robert, and he's like, well, sometimes these problems are actually thrust upon us by customers. So this is not just like I saw a shiny thing. Sometimes there are really important things that come up. But it does happen that we run into problems and then we're like, okay, am I going to stop what I'm doing and go fix that right away, or am I going to defer that? So these are ways we can lose focus. How do we try to maintain focus? And I'm going to talk about some of the things we've done that I think have been somewhat successful. One is this idea of a daily water cooler. And part of the idea here, so first of all, I'm going to try really hard to get through this slide without calling it a meeting, because a lot of people are like, wait, you tried to get people more focused by adding a meeting every day? I know some people feel that way, understandably. It's really important that this be optional. And there's also this thing of like, okay, yeah, you say it's optional, but like, do I really have to go every day? I've tried really hard to make sure it really is optional. So we don't make big decisions there. I don't always show up. Extended silence is fine. This is all fine. The idea here is to try to replicate the experience of working next to your colleague in the office, but remotely. So we open this meet for 30 minutes every day, and sometimes it's all silence. Sometimes it's people in the update team talking about like, I ran into this problem and I want to talk to some people about it. Sometimes it's like, I'm fighting diesel and I don't know what to do. It's a great time for people to surface those things. First of all, it's lower pressure. I think people don't like to interrupt their colleagues with problems. They want to have tried to solve it already, but it's low pressure to be like, well, I'm in the water cooler, I can just ask. It's also an opportunity for other people to ask, well, what are you working on? Oh, actually, I've been fighting diesel for the last 2 hours. I'm really freaking annoyed about it. Sorry to dump so much on diesel in this moment. It's the example I have in my head. I think this has been pretty helpful for keeping people unblocked on that sort of thing. And yeah, so that's it. I don't know if I called it a meeting. Hopefully I got through it. The next thing here is what I called making a path. I don't know what else to call this. So we as a team spend a lot of time both on the big picture stuff, like writing RFDs that are like, here's the vision for 6, 12 months down the road, or even a month down the road, whatever it is. But there's also a bunch of work that I put into trying to make sure that we have issues filed for the next N like work streams or people or however you want to think about it, so that when people do finish whatever they're doing, they have another thing that they can go to right away, if that, assuming that's the thing to do. I find this for myself is incredibly valuable. So for me, I will usually bite off like a pretty big project at a time. Like I'll say like 2 weeks or a month at a time. And I try to break it into small PRs. And I've got the first PR up, it goes into code review. I already got the next 2 or 3 in my head about what I want to go do next. And I want to get those in my pipeline. And I'm like trying to keep my pipeline full. I'm trying to help other people do that where it is helpful. Honestly, this is kind of hard for me because I'm not people's manager. I can't tell people what to do. And I also don't want to tell people, here's what you should be doing. And this is every single thing you should do for the next couple of weeks. So I feel awkward about it. But also, all the feedback I've gotten is that it has been helpful. So for my team, if this is annoying, please let me know. But hopefully it has been helpful. And I'm, in general, about this whole section, this whole talk, I would love feedback from the team about what's working and what's not. But I think that has been helpful for keeping people focused, myself included. But the other thing I want to emphasize is it takes time, and I'm actually not that good at this. I would say, you know, I have like a thing to do this every week, and I don't manage to do this every week. And then, you know, we do lose focus, and I'm like, I really wish I had spent a little more time on this. It's hard for me to, this is the procrastination of myself, I guess. Okay, I want to talk a little bit about demos. I think this is kind of preaching to the choir for most people here, but I do think it's worth saying out loud. Demos are such a great tool for focusing, because before the demo, you do a bunch of planning that forces prioritization. And the other sort of asterisk I want to say about this is there's a difference between like I just demoed something cool, which is cool and great, and I really don't want to discourage that, versus like I'm demoing a milestone that is on the critical path to the thing that we're doing and is like something that's ready to land on main. It's that second thing that forces the prioritization that is really like what I'm trying to get at here. The demo itself usually represents an important point of de-risk. You've done, like I've updated an SP. Okay, we know we can update an SP. Like the software exists, it can be done. That's an important point of de-risking. But afterwards, you have all this follow-on work, and it sustains momentum on this thing. People are like, oh, you could show progress if you did this. Oh, that'll hook into what I'm doing over here. Or maybe you're just like, and the next thing I want to do is this. That's really helpful. And for a lot of us, I actually don't know if it's all of us or most of us, but certainly for myself, it's incredibly motivating. Like Thursday, really all week, I'm like, I really want to get this demo in for demo day on Friday. And like on Thursday, I'm pretty focused. I'm trying pretty hard to make sure I can do that, and I'm a little bit sad if I can't. So I find that very motivating. But I also don't want this sort of thing to feel like pointless sort of management pressure, like out of touch pressure that's like, you need to have this demo on this date, and like that's the most important thing. It's not about that. But it is about this process, and it is about trying to do it, I think, frequently and showing where we are. It's also a great tool for communicating both within the team. This is what this thing is shaping up like, but also communicating with the rest of the company on how progress is looking. This has been really hard for Update because, as I said at the beginning, so much of this needed to be in place for us to be able to do what felt like a meaningful demo. And again, the key is finding those smaller demos along the way, and that was hard. But you know, the demo that we said we were going to do at OxCon late last year, like October last year, that I thought was going to be a couple weeks away, was more like 4 months away or 5 months away. But once we had done that, like 4 or 5 demos came right on its heels, because we'd actually done so much of the system at that point that the extension was pretty small. So in retrospect, I wish I had spent more time trying to find the stuff we could have demoed sooner, because I wound up adding that back to the plan of like, these are the demos we're going to do. Oh, we actually just like did all these things. Anyway, then we get to the prioritization question, which is a little bit related to the thing I called organizational procrastination. And the mechanism for this is me constantly asking people, is this really fixing this more urgent or important than taking the next step on upgrade? And it's hard. If you're hearing me ask this question, it's an earnest question. I don't know the answer usually. I might suspect that the answer is no, but if I knew that, I would probably phrase it differently. And it's tough because you're like, I could completely solve this important problem, or I could take a tiny baby step up the mountain. It's like, feels pretty good to solve a problem. And sometimes it's the right answer. But anyway, this is the only mechanism I have for that. And I'm part of why I'm socializing it is to help us all ask that question ourselves. I hope that people don't feel like I'm badgering them all the time about this. So prioritization, here I've adopted what I understand to be the dtrace mantra. I was not on the dtrace team, but I have been told that punt on third down was the motto for prioritization there. And the idea here is basically to just really, really focus as much as possible on what's truly required in order for this first thing before you start allowing scope creep to expand this thing into something you're never going to be able to deliver. So one of the things we had to constantly remind ourselves is that the MVP for self-service update need only be as correct and complete as the one that we were already doing at our customer site. So hopefully this is a good example. Our current MVP thing our current thing wasn't always doing SSD firmware update. So that can't be part of our requirements. Because if we keep adding scope to be all the things that we want to do, that's how we never deliver, right? A useful exercise, both in the small and in the large, is to ask yourself, what could we ship in 2 weeks, 6 months, whatever, a lot less time than you thought. And this sounds like the sort of thing Homer, the manager, might say to his team. Could you guys work any harder? Do you think you could just do it faster? But I actually think it's a really important exercise. And I would argue that this is how we got to where we are today. Because we didn't sit down and say, how long is it going to be before we can ship upgrade? That's what we're gonna say that we're gonna commit to. Well, we actually just said we are committing to shipping update in 12 months. We said that about 12 months ago or 15 months ago or something like that. And we made decisions to make that possible along the way. And I think that is really helpful. And it can change the way you're thinking about what is truly required, because you start asking, what can we throw out in order to hit that date? And if the answer is too much, then fine, the answer is too much. And you go back and say, we can't do anything less than that. But it's helpful to think about. The challenge we've had is there's not a lot of obvious scope or room to cut scope in software update, right? Because if the obvious way to do it would be to like, well, we only support updating the SPs or the SPs and the ROTs or the control plane. But if you're still doing them update, what's the point, right? You haven't delivered anything useful to the customer. But actually, what I have figured out only in the last couple of months is that there is a lot of room to cut scope and upgrade. It's not in the amount of stuff that it does, it's in the set of operational conditions that it can handle on a sunny day. And this is hard for me to get up here and say, because I feel like I'm getting up here and saying, let's just cut rigor. In the quality feature schedule, let's just cut quality. But I actually think that's not fair. I think it does sound that way, but it is also not fair. And it's better to phrase it in the way that I was describing earlier, which is like what we have is a deliverable that under many common conditions can do this thing that is much better for the customer. And this is really valuable for a lot of reasons. Even if a customer can't use that, I think it actually is really valuable because they can play with it in their POC rack, which a lot of our customers are doing. It shows them that we are serious about working on it, that we are making progress on it. It gives them an idea of how long it's going to be or how things are going. It de-risks a lot, again, for the same reason that the demos do. And there are many customers who are like, actually, I'm fine with that. And there's a later slide, but I'll mention this now. The thing that really like seared in my brain was when one of our customers asked me like, why don't you just let me do whatever it is you do on the tech port? I'm just going to run Wicket. I'm just going to run this bash commands that like do all this crazy stuff. And I've got like red lights and alarms blaring in my head because it's incredibly dangerous. There's so many things that can go wrong. You're wielding some combination of machete and scalpel on like, I mean, I don't even know what to call it. It's really dangerous. But from the customer's perspective is like, you're doing a thing. I can do that thing. Just train me on how to do it. It's been a reminder for me about the customer's perspective and the bar that they have. And it's not like I don't care about quality. It's just like, I don't need this thing to handle every case perfectly. I just need to be able to understand how to use it and operate it. I'm still not comfortable with them doing that, but it's still been a useful image in my head. So what we have been doing a lot in the last couple of months is we'll run into some problem, or not run into a problem, but we'll reach a point in the system we need to design. We build a design for it, and then we analyze it and say, okay, it seems to work in all these cases. But there are some edge cases here. Then we say, well, are those edge cases really important right now? And I'll talk about how we answer that question. If they are really important, then we just keep working on the design, fine. If they don't seem that important, then there's this question of like, do we need to solve this right now? And I think an important distinction here is we usually do spend the time to flesh out what it would look like to fix this in the current design, because these edge cases can absolutely inform the architecture. And that's really important too. You don't want to just like forget all these edge cases. And yeah, you think you've de-risked it, but the approach that you've taken is not on the road to where you need to go because of these edge cases that you chose not to think about. So there's a balance here. How do we prioritize these edge cases? They're the questions that you would expect that we would ask. Is this likely to come up? How bad is the impact? If the impact is permanent, like corruption in the control plane database, well, we're probably not going to punt on that one. If the problem is there's going to be a support call if this very unlikely thing happens, well, that's actually still better because there's already a support call to do the upgrade. So that's still an improvement. And in some cases, it's more like an operator annoyance, which I don't want to minimize. But in the grand scheme, if we have to choose between like slipping that further or dealing with every possible operator annoyance, for the most part, we're trying to get something in as soon as we can, especially, and again, it depends on how likely it is. If it's something they have to do, that's one thing. If it's an edge case, that's different. Big part of this is avoiding all or nothing thinking. And I like this example. Hopefully people won't feel like it's a terrible example, but we have this problem, which is when we update the host OS, we need to bounce the host OS. How do you bounce the host? The usual way to do it is you ask the SP to cut power. I should say the usual way. The way Pilot does it, for example, is that it cuts power, sleeps for 2 seconds, and then restores power, which is perfectly good for Pilot. It's not that great for Nexus, because what if you crash in those 2 seconds? You might think that's super unlikely, but that's likely enough, I think, that we're all a little bit uncomfortable saying, yeah, we're just not going to worry about that. That's the kind of not totally independent probability events, like you may crash because of that. What's that? You might also do it to your own sled. Thank you, John. So Nexus may be trying to reset its own sled's host OS, in which case you cut power, sleep for 2 seconds, but you're dead already. So you're not doing that. That's not going to work. You can fix that by creating a whole system for saying we're going to make sure that Nexus doesn't update its own sled. That has its own complexity and its own trade-offs. What if that's the only Nexus that's alive right now? And if we have a mechanism where that does work, then you don't have to have that constraint. Anyway, probably the best way to fix this, I think, is to have an API in the service processor that we can call through MGS that actually does the thing that Pilot is doing, but in the SP. And that's probably something we can do, but that will take a little bit of time. That involves plumbing through a lot of different places, working with another team, and that's not the very fastest thing that we can do. But at some point, John was like, well, what if we just reset the SP instead? We actually already have that API in the SP. We can just do that. And the impact is not that high because we're already resetting the host. And it sounds dumb, but I think it's a really good example of avoiding this all or nothing thinking, because we're not choosing not to handle this case, but we are choosing something that's not as ideal as we would like. It's got a bigger blast radius that we would like, but we can deliver it very quickly and has very low impact. And then we can still go do the thing we like better later. Obviously, the question we're always asking is, would we rather ship upgrade later in order to deal with this? That can sometimes be a circular thing because you're like, well, that's the question I'm trying to answer. What I sometimes find helpful is I imagine literally that same customer, but also other customers, asking them, would you rather wait for this update system a little bit longer in order to handle this case and then like be spending 30 seconds rattling off an extremely obscure case? And I think usually the answer is probably not, but I'm probably just biased towards thinking of the things we punted out. There have been many things for which the answer was like, no, we can't ship with that. And so we fixed those things. I have several slides of examples of things that we punted on like this, and I would love to talk about all these things, but that will take a long time, and I'm not sure we have the time to do that right now. I'm happy to do this anytime people do want to do it. Here's examples of edge cases where we're like, this seems really unlikely. It could happen. That all, for the most part, we've decided to punt on. And when I say punt, I also want to be clear. I guess it goes back to the question of impact. If we don't punt by saying we're just going to pretend like this can't happen. We punt by saying what's the impact of it? We're okay with that impact, and that is an important difference. Rollback, thank you for the question. Also on this list of punts, and I guess this is kind of the thing I'm least confident about. But there's this question of like, how do we as a company make all these priority calls? What I've just described is us making dozens of calls of the form, we are not going to handle this particular case, which is taking on some ongoing risk going forward. But there's this question of like, how do we as a company make those priority calls? How do we communicate them? And how do we keep track of them? Something that I think has been really useful for us, for me, creating this bucket of important non-blockers that we can put things in and know we're not going to lose track of that thing. We know that this is an ongoing risk. We're going to review that regularly. That's been really helpful for me. But I don't have that for the rest of the product. So for example, one of the things that I convinced someone to not work on was the fact that right now the external DNS, external IP addresses are not configurable. So if a customer came to us tomorrow and said, my network team is yanking this IP space from me, I need to update the rack, we wouldn't have a good answer for them. It's not related to upgrade at all, but it is in the neighborhood of stuff that like we could solve as part of Reconfigurator. I don't have a place to put that issue that's like, how do we make sure we don't lose track of that one? And I think it would be nice if we did. We do have the product roundtable for prioritizing a lot of the big stuff, and maybe that's a venue where we could talk about like the risks introduced by the update project this week or something. But anyway, I don't really know what the answer to this is, but hopefully something we can talk about. How am I doing on time? Okay, this is a little different from all the other stuff. This is a very concrete thing I kind of alluded to already that I did want to mention because as I put this presentation together, I realized we applied this trick in so many places that was incredibly useful. I mentioned we have all these circular dependencies between projects. We have resolved this several times with this trick of basically writing down a data structure and then using that as the point of interface between these things. And it sounds obvious when you say it, so much of this stuff does, but it just wasn't obvious at the time. So rendezvous tables is one I do want to mention, because this was a situation where I mentioned that the system has this plan execute pattern. It's making these blueprints. It's constantly evolving the current target blueprint. Fine. The blueprint is a really complicated data structure that Reconfigurator manages that keeps track of all kinds of intermediate state, including, for example, I've expunged this Nexus zone, but it might still be running, versus like I've expunged this Nexus zone and I definitely know it's not running, but there's still some cleanup to do, versus I've expunged this Nexus zone and there was some cleanup to do, but I finished doing it. But those details are like total inside baseball as far as the rest of the system is concerned. But there are all kinds of other parts of the system that want to know things like what Nexus zones are expunged. It's like, well, what do you care about is what I want to ask back. But for a while we had different subsystems in Nexus reading the target blueprint and then interacting with that thing. That was okay, but it didn't feel like it was going to scale very well for a bunch of different reasons. One of them is that we don't really want to have the whole control plane team have to know about all the guts of Reconfigurator in order to do anything at all. And so we created this idea of rendezvous tables, which is where if there's a piece of state that Reconfigurator can manage, is maybe responsible for managing, that other parts of Nexus need, rather than have them constantly be reading this blueprint and also being aware of blueprint execution and all these complicated lifecycle stuff around that, Reconfigurator itself will update these tables asynchronously that those things then use. And the best example of this that I can think of is we do this for storage for data sets that are available for use by like Crucible, for example. So that's right, that's one of the rendezvous, yeah. So when we want to go create a Crucible volume, we go find data sets on which to put the downstairs. That depends on what disks are in service, which is a whole Reconfigurator managed thing. But rather than have it know about all those guts, we create this data structure that's kind of an in-between point where Reconfigurator, when it removes disks and when it's going to add disks, makes sure it keeps this table up to date, and then the allocation code just uses that table. We've done this in a bunch of places. That's about all I had for all this stuff. The last thing I do want to say is I want to give a big thanks to the update team. It's been a long slog, and it's been an incredible team to work on. And not just because of what we've achieved, but also the teamwork along the way. We've had a lot of challenges. We've had a lot of new problems come up. We've had a lot of changing priorities all the time. And we've done a great job, I think, working together. Like at no point do I ever feel like people are not trying to do the best thing for the team. And that's just an awesome place to be. So I really appreciate that. And I hope we're all very proud of the team for everything that we've been able to do. And also everybody not on the team who's wound up doing stuff related to update, because I know it has touched a lot of places and will start touching even more places as everyone has to deal with API versioning. So thanks everyone who's been doing stuff for that. And I mentioned earlier, we have this water cooler. That's actually open to anybody. And we do have cases where people from other teams come in and are like, hey, I had this question about how update is going to intersect with something I'm doing. Come on by, we'll talk about it. We have 2 different time slots for different time zones, but we do it every day. Everyone's obviously welcome to join the Oxide update channel. And if you want to know more about the technical stuff, I've got some links to RFDs and the project board and all that stuff as well. And I think that is actually it. So thank you.